Hemp straw processing state of the art. Of the presentations that are reviewed, each will have their logo added to the page and contact details and websites added. Alex Thodorescu represented Cretis. The CTC is the Cretis Tech Centre, a brand new 900 metre square technology centre, and it showcases the versatility of their processing line for natural fibres, including decortication and fibre cleaning systems. The centre provides demonstrations, pilot projects and innovation. The challenge most noted for hemp growing is the equipment on the farm and interest in round bale processing, long fibre for textile application, emerging markets, and flax processes to combine the two. Technical fibre processing can produce fibre for textile, automotive, paper, composites and plastic applications. Hurd for bedding, construction, composites, fuels and cellulose. Dust for fuels, bioenergy, compost, plastic fillers. Within the technical fibre automated process, it can remove the strap from square bales, measure moisture, retting, can bale and stack, can perform traceability for quality measures or contamination, and can be automated for herd shives baling and stacking. Key considerations are who is my client and what is my market. These determine the percentage of herd from decortication or cleaned fibre. If the herd is raw or cleaned, what capacity, 2 tonne an hour, 4 tonne an hour or 7 tonne an hour, how much automation can be achieved. Michael Bider is the founder and CEO of FibreMax. Michael's pitch was about automation and the need to be able to scale to be competitive, especially in markets like China, whose expertise in automation is leaving all other countries behind. However, Michael is an advocate of the German efficiency model and not afraid to speak of the German expertise in this area. The photofinery concept is about focusing on the solution and using technologies to achieve it. The 5 core unique selling points are CO2 capture, a durable business model, German technology and efficiency, and a circular bioeconomy or field product model. Michael's use of imagery to illustrate the possible solutions was impressive, but without much content or evidence. At times, Michael was speaking above the audience with references to HMF and lignocellulosic carbon. I had to look up what the latter meant, and HMF is hydroxymethylfluoral, an industrial compound typically produced by dehydration of fructose converted from cellulosic biomass. It would have been advantageous if Michael was able to provide reference material to substantiate the production scale capabilities to see how they work together. R&D seems to identify new hemp varieties, cultivation, ag practices, efficiencies, automation and AI, and consistent product supply chain and transparency. It is unknown where Michael gathered the data from to show the social, environmental and economic impacts or the jobs value. Michael uses quotes from the EU President von der Leyen from the World Economic Forum January 2023 by validating how the EU can achieve the ESG goals. Maciej Kowalski was from Kombinat Konopny. The Polish have a different approach to growing and processing hemp. They use southern French varieties that do not mature. Flowers are small, which keeps the stems more pliable. They apply winter retting. Frost and rain removes pectins, a type of self-decortication, and it uses less energy to process and reduces the tensile strength. They use a 1,500 euro processor off the back of a tractor. They sow in May and harvest in April. They use repurposed machinery that was otherwise being used for flax, veg or grains. They produce 75% of the mass, which are shibs, and all are utilised. This QR code will link you to Maciej's LinkedIn profile. Vita Maria's presentation pack was very detailed. I've used a lot of her diagrams to replicate the key messages. This image is of a timeline of projects ranging from 2018 to 2027. They include cannabis waste, food reuse, and energy bio-valorization of oil, textile hemp for food and protein biomass for animal feed, hemp harvesting and post-harvesting for innovative and sustainable agro-industrial chains, development of testing of an industrial bioreactor for the extraction of hemp fibre, and the sustainable production of fabrics and building materials. The latest submission being an integration of hemp production into the regional textile ecosystem for sustainable, traceable, and circular production. This diagram shows the innovation, products, wastes, and final destination of the agro-industrial chain. This one refers to the bioreactor extraction of hemp fibre. The results from the hemp fibre extraction trial and further experiment details. This shows how the trial moved from the bioreactor TRL4 to TRL6. This diagram shows the versatility of the TRL6 system and its applications to hemp products. WP1 to WP6 defines how they progressed through the trial and distinguishes the products developed. The top diagram shows biochar cycle, the outcome achieved with carbon credits, green energy production, and new market opportunities. The one on the right shows the power ratio of biochar yield. Much of this slide is in Italian and is quite technical, but it may mean something to one of you. This diagram shows the further upscaling of the technology of TLR6. As you can see from the number of logos displayed, they have considerable support from government and industry. The goals are indicated on this slide to ensure profitability at all stages, products are sustainable, traceable, and good quality, and integrating ag production and transformation into a single supply chain. This is a nice diagram that included the business plan, innovation, traceability, production, training, and applications on farm. Vita Maria's email address is shown at the bottom left should you wish to make contact.